Okay, we're going to talk about graphing linear inequalities. Linear inequalities look like y is greater than or equal to mx plus b, or y is greater than mx plus b. Y is less than or equal to mx plus b, or y is less than or equal to less than. Okay? We graph them the same as we did yesterday. We still have to get y by itself. The difference is we are shading. When we did the number line and we had greater than or equal to, less than or equal to, we used filled in a solid circle on the number line. And that's going to translate to a solid line when we are graphing. If it is just greater than or less than without the equal to, we used an open circle, and that's going to be a dashed line for the linear equations. Okay. If they were greater than, we are going to shade up because up is greater than. And if they are less than, we are going to shade down. All right, so I have 4x minus 3y is less than or equal to 12. And I have 2x plus y is less than 3. We'll start by solving the bottom equation. And we need to get y by itself, so I want to move the 2x to the other side. By subtracting it, y is less than negative 2x plus 3. So, what is my y-intercept of this equation? What's my y-intercept? Negative 2x plus 3. Yes, positive 3, which is the point 0, 3. So I'm going to put that point on my graph. And what is my slope? Negative 2 over 1, which means I'm going to go down 2 and write 1. And then, so let me draw those points, down 2, right 1. Will this be solid or dashed? The equation is just less than, so will it be solid or dashed? It will be dashed. And am I going to shade up or down for less than? Down. Okay, so let me keep it all on your screen there. I'm going to connect this. The dashed line. So I have a dashed line and I am shading down. So I like to put my pen on the line and draw arrows down to show which side of the graph I am shading on. So this graph, and now you could leave it as just arrows, and then in the end decide where the arrows are both pointing at the same spot, or we can literally shade the whole thing. Because these shaded parts are all solutions for y is less than negative 2x plus 3. But the points on the line are not solutions because it's dashed, right? The points on the line are where it equals, y equals 2x plus 3, or minus 3, plus 3, negative 2x plus 3. And so the points on the line are not solutions. Okay, that's an important thing to realize. That's why it's dashed, to recognize that that's not part of the solutions, because it's only less than, not less than or equal to. Now we'll look at our second equation. Oops. 4x minus 3y less than or equal to 12. So I need to get y by itself. So I want to move the 4x to the other side by subtracting it. So negative 3y is less than or equal to negative 4x plus 12. And then we get y by itself by dividing by negative 3. And what has to happen when I divide an inequality by a negative? The sign changes. So it goes from less than or equal to greater than or equal to. And that's a positive 4/3 x minus 4. So what is my y-intercept? Right, negative 4 is my y-intercept. That's the point 0, negative 4. What is my slope? 4/3, which means up 4 and right 3. And then am I going to have a solid or a dashed line? Solid, because it's greater than or equal to. So let's see, we'll go to negative 4. Up 4/3. We'll connect with a solid line. And am I going to shade up or down? Greater than, up. Okay. So greater than, we're going to shade up. So that's this way. So that's shading. Now the points on the solid line are part of the solution. Okay. So where's my solution? Where do the colors overlap? Over here. Right? This is my solution area where it's a solution to both of the inequalities. I do not have to identify a point, because the point of intersection is actually not a solution, because it's not a solution of the dashed line. So I'm not identifying any points. The graph is my solution, is my work, because there's an infinite number of points in there that are solutions to these inequalities. Okay. Question. So when we have y equals a number, you have that horizontal line passing through that y value, and x equals a number is the vertical line passing through that x value. And that's because all of those points have the same x value. They all have an x value of 2 if it's 2, or they all have a y value of -2 if it was -2. And all the x doesn't affect what that value is. Okay, so what do our absolute value graphs look like? What does an absolute value function look like? Just graphed them on the test. No.
What was the question?
What does the absolute value function look like when we graph it? Were they V's? Wasn't the absolute value graphs V's that we were drawing last chapter? So your absolute value function is a V, so you will have some of those on there today, which means it has a vertex. What is the vertex of this equation?
4.
Right, +4, -3. And then the slope, or A, was what? The number in front of the absolute value, which is 1/1. So my graph is at +4, -3. I'm going to go up 1/1. And then I go up 1, left 1. so that I get that V-shaped. And make sure you're paying attention to whether it should be a V or it should be a line. Does it have absolute value in it? It should be a V. Now, should this be a solid or a dashed line if its y is less than the absolute value? Dashed. And less than shades up or down? Shade down. So I'm going to make a dashed line. And we're going to shade down. So that's everything under. All the points that are on the V are not solutions because it's less than, not less than or equal to. And everything under the V is a solution. Now when I'm graphing y is less than -2, I'm graphing the line y equals to, sorry, not a negative, which is a horizontal line at 2. It's less than or equal to, so it's solid. So that's this horizontal line. And less than is up or down? It's down. So we're going to shade down from this line. So that's all of this. And we can see where the coloring overlaps, right? This is a great assignment to break out 2 different color highlighters, 3 if there's 3 equations. And the color overlap shows you very clearly where that area is, the solution. So the solution is everything outside here and under the absolute value. Okay.